When we use the word and to signify a sequence of events, we use a multiplication rule. So this comes through so we see the word and, but it's more like and then. We want to find the probability of event A and then event B. So we want to find this probability of certain events happening in a certain sequence. And to do that, we multiply the probabilities. So we have our 10 jelly beans, 1 blue, 2 purple, 3 green, and 4 red. And from this set, we are actually going to draw 2 jelly beans. Sorry, that says 1 there, but we're getting 2 jelly beans. So if we draw the jelly beans with replacement, what's the probability of choosing a green jelly bean and then a red jelly bean? So for our notation, we use P of G for green and R. But just notice that this is really looking for the probability of green and then red. This can look very similar to probabilities we talked about before, where we see G and R, and it's the idea of drawing a single jelly bean and what's the probability it's green and red at the same time. But just note that this is a sequence of events. This is looking for 2. So it's like we have these 2 events. Event 1 is choosing the green jelly bean, and event 2 is choosing the red jelly bean. And what we do with these 2 events is we multiply the probability of each. Take the probability of G times the probability of R. Some important wording here is using with replacement. What that means is when we choose the green jelly bean, we put it back. So what it essentially does is it upholds all of the probabilities and how they're distributed. So where we start with 10 jelly beans in this distribution of colors, when we choose the second jelly bean, so during event 2, we have that same distribution. And this is the idea of independent events. And this will happen if we're drawing things with replacement. If we replace them, then nothing changes. But 2 events are independent if when one event occurs, it does not change the probability of the second. So, probability of drawing a green jelly bean is 3 out of 10. And then because we're drawing with replacement, the probability of choosing this red jelly bean, it stays the same as that 4 out of 10. So it doesn't change because we put that green one back and we have that same distribution. And this is going to be a 0.12. So there is a 12% chance of drawing a green jelly bean and then a red jelly bean with replacement is the important part there. So to show you why this works, I drew a tree diagram on this next page here to show why does that multiplication work. So we're going to move ahead a little bit, and I have this picture here showing all of the possible events. So event 1 is when we choose our first jelly bean, and there are 10 possibilities. We could get a blue, a purple, or that other purple. There's 3 greens that we could have chosen. There's 4 reds that we could have chosen. So we end up with these 10 branches here. Then when we move to event B of choosing a second jelly bean, these 10 options open up for each of those first 10 options. So if we went down this path, this first path of choosing a blue jelly bean, then for our second event, there are these 10 options. We could choose that blue again, purple, the second purple. We basically see this 10 same branches here. It's just off of that blue. And then we have that for each of the color. So overall, we have these 100 paths that we could follow with this act of choosing one jelly bean, putting it back, and then choosing a second jelly bean. So 100 different paths that we can follow. But what we want to focus on is choosing that green jelly bean. So we want to focus on these 3 cases where we see G come through, and then we specifically want these cases where R comes out next. And what we're going to see in terms of how many possible ways that can occur to have G and then R, We have 4 from that first set, 4 from the second, 4 from the third, for 12 total possibilities. So there's our 12 out of 100, which is that 0.12, that 12% that we get out. So the multiplication rule is very nice because this is a very tedious way to go about drawing all of the possible samples that can come out, but this is to show why that works. So if two events are independent, that the probabilities aren't changing with each event as they occur, then if we're looking for the probability of one event and then the other, you just multiply the probabilities together. So what if we didn't have independence? That's going to be what happens if we work without replacement. So let me just write out the letters for our 10 jelly beans here. We have 1 blue, 2 purple, 3 green, and 4 red. So if we draw jelly beans, what is the probability of choosing a green jelly bean and then a red jelly bean? So let's start with using our multiplication rule. So we're looking for this probability of green and red. But when we write our probabilities, so we have our first event is just the probability of drawing a green jelly bean. That's not going to change. That's still going to be 3 out of 10 there. But now we need to pay attention to our second event when we choose our second jelly bean. We want to find the probability of choosing a red jelly bean, but given a green jelly bean was removed. So if we think about this box or bag of jelly beans, and we have a blue, 2 purple, 3 green, 4 red, we choose our first jelly bean, and we take 1 green jelly bean out and we don't put it back. So if we look at our sample, what's going to happen is we remove one of those green jelly beans. So now we have 1 blue, 2 purple, 2 green, and 4 red. So we take our 3/10 for our probability of a green, and we multiply with this probability of choosing a red jelly bean given a green was removed. So for our numerator, the number of red jelly beans, we have 4. But what changes is our denominator because now we only have 9 jelly beans to choose from. This second part here is called a conditional probability. So that there was a condition of something was given to change how that probability is calculated. So this would be a 0.1333. So there is a 13.33% chance of choosing a green jelly bean and then a red one if we do not replace them. So if they're independent, you just multiply the two probabilities. If they're not independent, then you just have to be careful with that second probability and how it has changed.